अच्छा.
आवाज येते का मला? सध्या आहे काय?
ठीक आहे, ठीक आहे.
हो हो
नंतर बाहेर फोटो घेतो.
हो हो
ठीक
हो
आहे.
हो. बसा
लगेच फोटो पाठव.
बसा.
हं?
हो. आवाज रिपीट येऊ नये.
नाही.
जॉईन झाले जराचे किती आहे?
त्यांनी बंद केले फक्त सरांचा व्हिडिओ दिसावा असं सेटिंग केलं खाली मला दिसेल चला करते
सुद्धा मी केलं.
स्टार्ट.
हा चालेल. हा चालेल.
सुरू करू एक कसं हे तुमच्या पुढे
इथं दिसत नाही. तुम्हाला काल लिंक लिंक आहे का लिंक आहे?
त्यांना दिसणार का तुम्ही लिहिलेलं?
पार्टी आहे का मग?
अंदाज घेता तिथं दाखवता येते ना, त्यांनी दिसतंय.
पार्टी आहे. हा
दिसते.
आहे कसले जवळ?
तर मी तोंडी बडबडून काय चालणार नाही. बॉलबॅक ते बोलू शकतो.
हे तोंडीच हे करा कारण
तांडे तोंडीच बरोबर चालते काय काय नंबर होते काय आता हे ह्याच्यावरती बोलताना रिपीट वगैरे काय लागत नाही.
पाहिजेच काय करायचं मग ते कॉलेजला गेलीत का काय काय करायचं मग ते टकलूचा फोन आला तर जाणार आहे काय म्हणून म्हणलं काय आमचं ठरलेलं नाही अजून
वी आर कुंभार तुमचा माईक चालू आहे म्यूट करा वी आर कुंभार तुमचा माईक चालू आहे तो म्यूट करा वी आर कुंभार
म्यूट करा आपला म्यूट करा आवाज येतोय
सरांची ओळख
काय देतो
काय म्हणता हेच करायचं पाच रिसर्च
शिक्षण व ऑनलाईन शिक्षण केंद्र अंतर्गत गणिताच्या वतीने आज दिनांक 22 डिसेंबर 2023 रोजी आपण राष्ट्रीय गणित दिनानिमित्त संख्यात्मक सिद्धांत या विषयावर ऑनलाईन व्याख्यान आयोजित केलेले आहे. या व्याख्यानासाठी मार्गदर्शन करणारे शिवाजी विद्यापीठाचे गणित अधिविभागाचे सेवानिवृत्त प्राध्यापक डॉक्टर CS मांजरेकर, मार्गदर्शन करणार आहे. त्यासाठी मी विनंती करते की दूरशिक्षण केंद्र समन्वयक प्राध्यापक डॉक्टर के.बी. पाटील यांना त्यांनी प्रमुख पाहुण्यांचे स्वागत व प्रास्ताविक करावे.
धन्यवाद भोसले मॅडम. शिवाजी विद्यापीठ कोल्हापूर दूरशिक्षण व ऑनलाईन शिक्षण केंद्र यांच्या वतीने आज गणित दिनानिमित्त विशेष व्याख्यान आयोजित केले आहे. व्याख्यानाचे अध्यक्ष प्राध्यापक डॉक्टर डी.के. मोरे सर, प्रमुख उपस्थिती डॉक्टर एस.एम. कुबल सर, श्री सी.एस. कोथमिरे सर, तसेच माझे सर्व सहकारी आणि आजचे प्रमुख व्याख्याते प्राध्यापक सी.एस. मांजरेकर सर व सर्व सहभागी या सर्वांचं मी मनपूर्वक स्वागत करतो. आज नॅशनल मॅथमॅटिक्स डे अर्थात राष्ट्रीय गणित दिन हा संपूर्ण भारतासाठी अत्यंत अभिमानाचा असणारा दिवस आहे. आजच्या दिवशी म्हणजे 22 डिसेंबर 1887 मध्ये महान गणितज्ञ श्रीनिवास अय्यंगार रामानुज यांचा जन्म कोइंबतूरच्या इरोड गावात झाला होता. देश आणि जगातील काही महत्वपूर्ण गणितज्ञांमध्ये त्यांचं नाव गणलं जातं. रामानुज यांनी फक्त गणितालाच वेगळी ओळख दिली नाही, तर त्यांनी अशी काही प्रमेय आणि सूत्र दिली ज्यांचा आजही मोठ्या प्रमाणात वापर केला जातो, जे बरेच महत्वपूर्ण उपयुक्त म्हणूनच फायद्याचे ठरतात. वयाच्या 32व्या वर्षी रामानुज यांचं निधन झालं. 2015 मध्ये त्यांच्या जीवन प्रवासावर प्रकाशझोत टाकणारा हू न्यू इन्फिनिटी हा चित्रपट प्रदर्शित झाला होता. या चित्रपटात त्यांच्या जीवनावरील अनेक प्रसंग साकारण्यात आले होते. 1976 मध्ये ट्रिनिटी कॉलेजच्या पुस्तकालयात एक जुनं रजिस्टर मिळालं होतं, ज्यामध्ये अनेक प्रमेय सूत्र लिहिण्यात आली आहेत. या प्रमेयांना अद्याप कोणीही सोडू शकले नाही. हे रजिस्टर रामानुज नोटबुक या नावाने ओळखलं जातं. अशा या भारतीय गणितज्ञ श्रीनिवास रामानुज यांच्या जीवन कार्याला सन्मान करण्यासाठी 2052 साली त्यावेळेसचे पंतप्रधान मनमोहन सिंग यांनी हा दिवस राष्ट्रीय गणित दिन म्हणून जाहीर केला आणि आजही त्यांच्या कर्तृत्वाला सलाम करण्यासाठी दरवर्षी 22 डिसेंबर हा दिवस गणितज्ञ दिन म्हणून साजरा केला जातो. परंतु दूरशिक्षण केंद्रामध्ये किंवा शिक्षण क्षेत्रामध्ये, शैक्षणिक संस्थांमध्ये हा दिवस का बरं साजरा करायचा, हा एक महत्वाचा प्रश्न एक शिक्षक, एक विद्यार्थी म्हणून विचारला जातो. आपण बघतो की शालेय जीवनापासूनच गणिताबद्दल एक वेगळी भीती किंवा काही वेळेला वेगळा विचार विद्यार्थी करतात आणि सर्व विविध विद्यार्थ्यांना गणिताप्रती अभिरुची वाढावी, त्यांची अभिवृत्ती अधिक सकारात्मक व्हावी, त्यांच्यामध्ये अभियोग्यता विकसित व्हावी, ह्यासाठीच हा दिवस मोठ्या प्रमाणात साजरा केला जातो. अतिशय झपाट्याने नव्या गोष्टी आत्मसात करण्यासाठी झोकून देणाऱ्या नव्या पिढीचा गणिताकडे कल वाढवणं हा इथं पाठीमागचा हेतू आहे. आणि म्हणूनच आज आपण प्राध्यापक सी.एस. मांजरेकर सर यांचं संख्यात्मक सिद्धांत यावर आयोजित केलं आहे. गणितामधील संख्या सिद्धांत या शाखेने गेल्या 2500 वर्षात अनेक प्रसिद्ध गणितज्ञांचं लक्ष वेधून घेतलं आहे. ग्रीक, भारतीय व चीनी गणितज्ञांनी या शाखेमध्ये मोलाची भर घातली आहे. गौस यांच्या डिस्क्रिमिनेशन अर्थमॅटिके या ग्रंथात 1801 मध्ये प्रसिद्ध झाला. तो संख्या सिद्धांतातील एक मौलिक ग्रंथ आहे. गौस यांनी म्हटलंय की गणित हा सर्व विज्ञान शाखांची सम्राज्ञी आहे आणि संख्या सिद्धांत हा गणितातील सम्राज्ञी आहे. आणि याच गणितातील सम्राज्ञी म्हणजे संख्यात्मक सिद्धांतावर आपण आज प्राध्यापक सी.एस. मांजरेकर सर यांचे विचार ऐकून घेणार आहोत. त्यासाठी मला प्रास्ताविक आणि स्वागताची संधी संयोजकाने दिली, त्याबद्दल कृतज्ञता व्यक्त करतो. आणि ओव्हर टू श्रीमती जी.एस. भोसले.
धन्यवाद सर. यानंतर गणित विषयाचे सहाय्यक प्राध्यापक श्री गावडे यांनी करून द्यावी.
नमस्कार. मी सहाय्यक प्राध्यापक गणित दूरशिक्षण केंद्र शिवाजी विद्यापीठ कोल्हापूर. आपल्याकडे आज राष्ट्रीय गणित दिन या निमित्त संख्यात्मक सिद्धांत या विषयावर व्याख्यान देण्यासाठी डॉक्टर सी.एस. मांजरेकर सर आज उपस्थित आहे. CS मांजरेकर सर यांच्याबद्दल सांगायचं झालं तर मांजरेकर सर हे गणित अधिविभाग शिवाजी विद्यापीठ कोल्हापूर इथून प्राध्यापक पदावरून ते 2010 साली रिटायर झालेले आहेत. त्या अगोदर त्यांची विवेकानंद कॉलेज कोल्हापूर येथे 18 वर्ष अध्यापनाची सेवा झालेली आहे. नंतर 1990 ते 2010 20 वर्ष गणित अधिविभाग शिवाजी विद्यापीठ कोल्हापूर येथे PG म्हणजे MSc ला अध्यापनाची सेवा झालेली आहे. त्यानंतर सेवानिवृत्तीनंतर त्यांना एक संधी मिळालेली होती. राणी चन्नम्मा विद्यापीठ बेळगाव येथे सुद्धा त्यांनी 10 वर्ष अध्यापनाची सेवा केलेली आहे. आणखी त्यांचा जो हातखंडा आहे मांजरेकर सरांचा जो हातखंडा आहे तो नंबर थेरी आणि अल्जेब्रिक नंबर थेरी याच्याबद्दल त्यांचा फार मोठं प्रभुत्व आहे. आपल्या शिवाजी विद्यापीठामध्ये त्यांनी जे सब्जेक्ट जे आणलेले आहेत अभ्यासक्रमामध्ये नंबर थेरी, अल्जेब्रिक नंबर थेरी, लॅटाईस थेरी, फंक्शनल अनालिसिस आणि अजून सुद्धा ते बनाक अल्जेब्रा अजून सुद्धा ते सेवानिवृत्तीनंतर सुद्धा त्यांचे सब्जेक्ट अजून सुद्धा ते चालू आहे. आणि त्या सब्जेक्टवर आपल्याला सेट क्वेश्चन पेपर सुद्धा येतात किंवा MPSC UPSC ला सुद्धा ते क्वेश्चन पेपर येतात. याच्यामधला जो अभ्यास आहे तो मांजरेकर सरांचाच आहे. मांजरेकर सरांचा जसा संशोधनाचा प्रभाव फार मोठा आहे. त्यांचे 5 रिसर्च स्टुडंट आता बाहेर आहेत म्हणजे PhD घेऊन PhD अवॉर्ड घेऊन ते बाहेर आहेत. अगदी भरपूर असे रिसर्च पेपर त्यांचे पब्लिश आहेत नॅशनल इंटरनॅशनल कॉन्फरन्समध्ये. असे हे व्यक्तिमत्व आपल्याला आज प्रमुख पाहुणे म्हणून गणित दिनानिमित्त लाभलेले आहेत. तरी त्यांनी आपलं व्याख्यान चालू करा ही विनंती.
धन्यवाद सर. मी आता विनंती करते की आपले व्याख्याते डॉक्टर CS मांजरेकर यांना की त्यांनी राष्ट्रीय गणित दिनानिमित्त संख्यात्मक सिद्धांत या विषयावर मार्गदर्शन करावे.
Okay, good afternoon, everybody. Today I'm going to talk on prime numbers in Goldbach conjecture. You know that integer greater than 1 is called prime number if its only positive divisors are 1 and itself. And the first important result is the number of primes infinite. Before that, I will say something about fundamental theorem of arithmetic. Fundamental theorem of arithmetic is every integer greater than 1 can be written as a product of primes. This representation is unique apart from the order in which these prime factors occur. Now we shall see how the number of primes is infinite. Suppose the number of primes is finite and the only primes are P1, P2, Pn in increasing order. Correct? Let capital N let capital N equal to P1, P2, Pn plus 1. And obviously this in number is greater than 1. So it is divisible by some prime P. But the only primes are P1, P2 and Pn. So now P divides N. Also, P divides P1, P2, and Pn. So P divides N minus P1, P2, and Pn. What is N? P1, P2, Pn plus 1 minus P1, P2, Pn. So this implies that P divides 1, a contradiction, because prime number P is greater than 1. And this contradiction shows that the number of primes is infinite. Now we shall see what is P star plus 1. Suppose P star is the product of primes less than or equal to P. And we shall see what is P star plus 1. Now, what is P star? P star is the product of primes less than equal to P. So, now, what is P star plus 1? P star is product of prime less than equal to P. Now, we shall see what is 2 star plus 1. 2 star plus 1 is 2 plus 1, that is prime. Then what is 3 star plus 1? This is 2 into 3 plus 1. This is prime. What is 5 star plus 1? This is 2 into 3 into 5 plus 1. This is again prime. Similarly, 7 star plus 1 is prime. 11 star plus 1 is prime. But 13 star plus 1 is composite. Composite number means it is not prime. 17 star plus 1, you can check this, it is composite. Again, 19 star plus 1 is also composite. So the question whose answer is not yet known is how many primes are there? How many primes are there for which P star plus 1 is prime? At present, 15 primes are known for which this P star plus 1 is prime. At present means when I read this article 20 years back, now this number could be different. So the open problem is how many primes, whether there are infinite number of primes for which P star plus 1 is prime. Again, we shall go to the next result. We shall see some infinite sequence. Consider, say, n1 equal to 1, n2 equal to n1 plus 1, n3 equal to n1 into plus 1, and similarly nk equal to n1 into nk minus 1 plus 1. So how many nks are there? There are infinitely many nks. We shall see that any two nks are relatively prime. So consider two different ni and nk. Let d equal to GCD of ni and nk. GCD means greatest common divisor of I and k. So I less than k. Now I less than k means this ni is one of the numbers n1, n2, and nk minus 1. Now d is the greatest common divisor of n and nk, means d divides ni, d divides nk. So d divides n1, n2, nk k minus 1 because ni is one of the numbers from n1 to nk minus 1. Now d divides nk, d divides n1 into nk minus 1. This implies that d divides nk minus n1, n2, and k minus 1. Now let us put the value of nk. So d divides nk is what? Nk is I have written here n1, n2, nk minus 1 plus 1 minus n1, n2, and k minus 1. So what this implies? This implies that d divides 1. And what is the smallest positive integer? 1. So d equal to 1. So d equal to 1. Now what we have proved? Greatest common divisor of any two different ni's is 1. And when the greatest common divisor of any two numbers is 1, these numbers are said to be relatively prime. Now, and what this shows? Any two nks cannot have the same prime divisor. And all these are n2, n3, etc. greater than 1. So, the prime divisors of n1, n2, nk are all distinct. And how many nks are there? Infinitely many. So this is another proof of the fact that there are infinite number of primes. Now we shall see the next result. Now by induction, it's obvious that you can see that if P1, P2, Pn are the primes in increasing order, then Pn plus 1, Pn plus 1 now we can see that Pn plus 1 is less than equal to P1, P2, Pn plus 1. Now, what is P1? What is P1? The first prime number is 2. The next is 3. Next is 5. So we can see Pn plus 1 less than equal to P1, P2, Pn plus 1. This can be proved by this induction. Now the next result is for any prime P, Pn is less than equal to 2 raised to n minus 1. Correct. N minus 1 less than. One number. Correct. Correct. Yes, you can see that this result is true for 1 because first prime is 1. P1 is less than equal to 2 raised to 2 raised to 0, or 2 less than equal to 2. The result is obvious. Now assume that the result holds for P1, P2, Pn. We shall prove that the result holds for Pn plus 1. So, what is Pn plus 1? Pn plus 1 less than equal to P1, P2, Pn plus 1. Now we are assuming the above result for all the numbers up to n, and therefore Pn plus 1 is less than equal to, what is P1? Put n equal to 1 in the above result. So 2 raised to 0 into 2 raised to 1. And what is Pn? 2 raised to n minus 1 and plus 1. That is equal to 2 raised to 0 is 1 plus 2 square plus 2 raised to n minus 1 and plus 1. That is equal to 2 raised to, this is geometric series, and it is 2 raised to n minus 1 upon 2 minus 1 plus 1. Therefore, Pn plus 1 less than equal to 2 raised to n minus 1 plus 1. But 1 is always less than equal to 2 raised to n minus 1. This is less than equal to. That takes here. So Pn plus 1 less than equal to 2 raised to n minus 1 and plus 1, that is equal to, but 1 is always less than equal to 2 raised to n minus 1 plus 2 raised to n minus 1. That is equal to 2 times 2 raised to n minus 1. That is equal to 2 raised to n. Now minus 1 will get cancelled because we are taking it 2 times, and the spot we have proved. That we have proved that Pn plus 1 less than equal to 2 raised to n plus 1 minus 1. The result holds for n plus 1. So by induction, it holds for all n. So our result is Pn less than equal to 2 raised to n minus 1 for all n. Now we shall see what are the reap units. What are the reap units? A reap unit is an integer which consists of only ones. Digits are only ones. So this is the reap unit. This is a reap unit. So digits are only ones. Now we shall denote by R2, REP unit consisting of 2 ones. R3, a REP unit consisting of only 3 ones. Similarly, Rn. Now, we shall see how many primes are there among REP units. There are only few primes known in REP units, and so far only few primes are known which are REP units, and no conjecture has been found as to the existence of any other prime. Now we shall see what are twin primes. There are primes like this, which are very close together, say 3 and 5. Correct? These are primes. Again, 11 and 13, these are primes. Correct? 17 and 19, these are primes. Correct? 19. These primes are very close together. Such primes are called twin primes. Such primes are called twin primes. And again, the open problem is how many REP units twin primes are there. Whether such pairs of twin primes are finitely many or infinitely many. The open problem is how many twin primes are known, whether these are finitely many or infinitely many REP unit twin primes. The largest pair of twin primes known. The largest pair of twin primes known to this date is. The largest pair of twin primes known to this date is 1, 0, 7, 5, 7, 0, 4, 6, 3 into 10 raised to 2 to 5, 0 plus minus 1. So this is largest pair of twin prime, and this was found, and this is each is 2259 decimal digits long. So what is the length of this prime? 2259 decimal digits long, and this was discovered in 1985. Now, and the primes are very close together. There are some gaps in the sequence of integers. There are long gaps in the set of integers which are without any prime. Give me any integer n. So we can find n consecutive composite numbers. Composite number means which is not prime. Give me any integer n. Now let us write n plus 1 plus 2, n plus 1 factorial sorry, n plus, I want to write actually n plus 1 factorial plus 2. See, n plus 1 factorial plus 2. Now take 2 common. Take 2 common from n plus 1 factorial. We have 1, 3, and n plus 1, and plus 2. This is a composite number. Again, let us consider n plus 1 factorial plus 3. Take 3 common, then we have 1, 2, 3 is taken out, 4, n plus 1 plus 1. This is again a composite number. And finally, n plus 1 factorial plus n plus 1. This is equal to, take n plus 1 common, and we have 1, 2, 3 up to n, and n plus 1 is taken out. N. So first number is composite, second is composite, third is composite. So how many these numbers are there? These are n consecutive integers which are composite because the factors are greater than or equal to 2. And now we shall see what is a Fermat number. What is a Fermat number? We shall see now. Now, integers of the form 2 raised to 2 raised to n. 2 raised to 2 raised to n plus 1 is called a Fermat number. This is called a Fermat number. Here n is greater than or equal to 0. So Fermat numbers are all odd numbers. Now we shall see that here we shall denote this by Fn. We shall see that any two Fermat numbers are relatively prime. Relatively prime means what? The greatest common divisor is always 1. Now take m greater than n greater than equal to 0. Now let d equal to GCD of Fm and Fn. And GCD means what? Greatest common divisor of these two numbers, Fm and Fn. I want to show that this greatest common divisor of Fm and Fn is 1. So they will be relatively prime. Now, Fermat numbers are always odd numbers because the number is 2 raised to 2 raised to n plus 1. Now, power of 2 is even plus 1. So, every Fermat number is odd. So, their greatest common divisor is also going to be odd. Now, consider Fm minus 2 upon Fn. Now, this can be written as 2 raised to n raised to 2 raised to m minus n and minus 1 because we are subtracting minus 2, so 1 from Fm will get cancelled. Now, upon what is Fn? 2 raised to n plus 1. Now, put x equal to 2 raised to n. Sorry, x x put x equal, sorry, x equal to 2 raised to n and k equal to 2 raised to m minus n. Now we shall see what is fm minus 2 upon fm. Now in this case, fm minus 2 upon fn equal to, right hand side is 2 raised to n, that is x raised to k minus 1 upon x plus 1, and that is equal to x raised to k minus 1 plus minus x raised to k minus 2 plus x minus 1. Now, this much. So last term is x minus 1, and what this implies? The last term is x raised to k minus 1 minus x raised to k minus 2 plus x minus 1. So this implies that fn divides fm minus 2. Now, d divides d equal to GCD of fm and fn. So, d divides fm, d divides fn. Also, d divides fm minus 2. So, d divides fm and d divides fm minus 2. Hence, d divides fm minus fm minus 2, that is plus 2. So this implies d divides 2. But these odd integer, as these odd, d has to be equal to 1. So what we have proved? The greatest common divisor of any two distinct Fermat numbers is 1. So Fermat numbers are relatively prime. Now we shall see the next property of Fermat numbers. Now we know that Fermat number is form 2 raised to 2 raised to n plus 1, and here n greater than or equal to 0. The product of the first k format numbers is the product of the first n format numbers is 2 raised to 2 raised to n minus 1. Now, what is the first format number? First format number is F0. That is 2 plus 1 equal to 3. What is the next format number? F1 is equal to 2 square plus 1. What is the next format number? F2 is 2 raised to 2 raised to 2 plus 1. And that is equal to 17. Now, what is F0, F1? The product of the first two format numbers is 3 into 5, that is 15, that is equal to 2 raised to 2 minus 1. So the result holds for the product of the first two format numbers, correct? Now assume that the result holds for the product of the first k format numbers. Assume the result for n equal to k. So in this case, F0, F1, F2, Fk minus 1 is 2 raised to 2 raised to k minus 1. Next, F0, F1, Fk minus 1 and Fk equal to 2 raised to 2 raised to k minus 1. This is the product of the from F0 to Fk minus 1 into 2 raised to 2 raised to k plus 1. Correct? So product of these two numbers is 2 raised to k plus 1 minus 1. Thus, what we have seen, the result holds for k plus 1, and therefore the product of the first n format numbers is 2 raised to n minus 1. Now, let us come to the next result. A composite integer n is called a pseudo prime. We shall see what is pseudo prime. A composite integer n is called pseudo prime. if n divides 2 raised to n minus 2, and this is same as 2 raised to n congruent to 2 mod n. And composite integer means what? It is not prime, and we shall see this next result. And before going to Goldbach conjecture, this is my last result. If n is pseudo prime, then 2 raised to n minus 1 is a pseudo prime. Now, since n is pseudo prime, it's a composite number. Since n is pseudo prime, it is a composite number. And composite number means what? This is not prime. So n is of the type R into S, where 1 less than RS and less than N. Again, we use the result. We use the result if M divides N, then uh, 2 raised to M minus 1 divides 2 raised to N minus 1. We shall use this result to prove our main result. Now, what we have, so R divides N. R divides N, and hence R divides N. So 2 raised to N minus 1, 2 divides R minus 1 divides 2 raised to N minus 1. So what it shows? 2 raised to R minus 1 divided 2 raised to N minus 1. So N equal to 2 raised to N minus 1 is a composite number. So first condition is satisfied. Now this is a composite number. And what we have? We prove that we prove that 2 raised to N congruent to 2 mod N. And what is N? N equal to 2 raised to N minus 1. That is what we are going to prove. We have, since N is pseudo prime, we have 2 raised to n congruent to 2 mod of n. And therefore, so we have n divides 2 raised to n minus 2. So this implies now n divided 2 raised to n minus 2. So 2 raised to n minus 2 equal to kn for some integer k. Now 2 raised to n minus 1 is equal to capital N. So 2 raised to n minus 2 is n minus 1 equal to kn. रास्ते पुट्टा सुधे रास्ते सुधे Now n minus 1 here divides kn. Again, n obviously divides kn. So 2 raised to n minus 1 divides 2 raised to kn minus 1. And this implies that 2 raised to kn minus 1 congruent to 0 mod of n. This, but what is kn? Put the value of kn. Kn is equal to n minus 1. 2 raised to n minus 1 is congruent to 1 mod of n. Now this multiply by 2 on both sides. So 2 raised to n congruent to 2 mod of n. So this shows that n is associative prime. N is. So what is the result? If n is pseudo prime, then 2 raised to n minus 1 is also pseudo prime. So how many pseudo primes are there? Infinitely many, because from one pseudo prime we can get on second one, from second we can get third one, and so on. And lastly, let us come to what is Goldbach conjunction. This is Goldbach conjecture. In 1742, Christian Goldbach wrote a letter to Euler. Euler was a very great mathematician. He has published more than 600 research papers. Goldbach wrote a letter to Euler in 1742, and in which he guessed that every even integer greater than 4 every even integer greater than 4 is the sum of two odd primes. Now you can also enjoy this because every even integer greater than 4 means what? Greater than 4 even integer is first integer is 6. What is equal to 3 plus 3, correct? Every even integer greater than 4, 8 is 3 plus 5 plus 3. Again, 10 is equal to 3 plus 7. 12 is equal to 5 plus 7. What is 14? 7 plus 7. What is 16? It is 5 plus 11. Correct? So you can go on, and it is verified by direct computation for all even integers up to 10 raised to 8. Although many calculations suggest that Goldbach conjecture is true, but no mathematical proof is given so far. So it is far from the mathematical proof. Now, great Russian mathematician Vinogradov, he showed that he is a Russian mathematician. He showed that Russian mathematician showed that if x is the number of even integers, less than equal to x, which are not the sum of two primes, which are not the sum of two primes, then a limit of x upon x and x tends to infinity equal to 0. And this allows us to say that Goldbach conjecture is true for almost all even integers. As Edmund Landau put it, the Goldbach conjecture is false for at most 0% of all even integers. But this 0% does not exclude the possibility that there are many exceptions, because this is just a limiting value. So Goldbach conjecture is still unsolved. So we can try to show that what is our conjecture, what is the meaning of conjecture in Marathi. What is the meaning of conjecture in Marathi? Atkal. Where is Professor Gowde? He must have gone for tea. This is Atkal, but he must have gone somewhere else. So there are thousands and thousands of such conjectures. And this is very simple conjecture. Every even integer greater than 4 is the sum of two odd primes. And this conjecture, it looks very simple, but it is still unsolved. Another conjecture is like Fermat's theorem. What is x square plus y square equal to z square? This is our this Pythagorean triple, correct? 2, 3, and 5, correct? 2 square plus 3 square, 3 square plus 4 square equal to 5. This is the Pythagorean triple. My next question is, x at 20 plus y at 20 equal to z at 20. Is it true for n equal to 3? Is it true for n equal to 3? Is it true? Some more values. No. X cube plus y cube equal to z. Can you give me the values of x, y, z satisfying this 3 and greater than equal to 3? The conjecture is very simple. What is the answer? Can you try for 2 days, 3 days, 4 days and give me the value? This conjecture is not true. You cannot find x cube plus y cube equal to z cube, 3 values for x, y, and z. And this is not, this doesn't hold. This is proved in, I think, in 2005 or so like that. And to prove this, one research paper of more than 100 papers was published, and so many calculations are involved, like algebra, topology, real analysis, and complex analysis. So this was formatted last year. X raised to n plus y raised to n equal to z raised to n is not solvable for n greater than equal to 3. So this is also such a problem. What is this Goldbach conjecture? Every given integer greater than 4 can be written as the sum of two odd primes. Of course, this expression is not unique because what is 16? 5 plus 11. It could be another different result. It could be another two pairs of odd primes. So Goldbach conjecture is every given integer greater than 4 is the sum of two odd primes. You can take this problem forward creatively. Thank you. Thank you very much. Like इतिहास बदल असतो. गंगा त्याचा आम्हाला हँडेड चांगला होते. but we are not that proper. हे पाहिजे थोडं. बरोबर.
थँक्यू सो मच मांजरेकर सर. मी यानंतर डॉक्टर रणदिवे सर यांना विनंती करते की त्यांनी आभार व्यक्त करावे.
धन्यवाद भोसले मॅडम. आजच्या या दूरशिक्षण व ऑनलाईन शिक्षण केंद्राच्या वतीनं राष्ट्रीय गणित दिनाच्या निमित्तानं शिवाजी विद्यापीठाचे गणित आदी विभागाचे सेवानिवृत्त प्राध्यापक CS मांजरेकर सर यांनी आपल्या सर्वांना संख्यात्मक सिद्धांत या विषयावर अतिशय अनमोल असं मार्गदर्शन केलं. त्याबद्दल मी सर्वप्रथम दूरशिक्षण व ऑनलाईन शिक्षण केंद्राच्या वतीनं त्यांचे या ठिकाणी आभार व्यक्त करतो. त्यानंतर या कार्यक्रमासाठी प्राध्यापक डॉक्टर DK मोरे, संचालक दूरशिक्षण केंद्र व ऑनलाईन शिक्षण केंद्र, तसेच उपकुलसचिव SM कुबल, CS कोथमिरे यांनी हा कार्यक्रम आयोजित करण्यासाठी आम्हाला प्रोत्साहित केलं. त्याबद्दल मी त्यांचे या ठिकाणी आभार व्यक्त करतो. तसेच या कार्यक्रमाचे स्वागत व प्रास्ताविक या केंद्राचे समन्वयक प्राध्यापक डॉक्टर KB पाटील सर यांनी केले. त्याबद्दलही मी त्यांचे या ठिकाणी आभार व्यक्त करतो. तसेच पाहुण्यांची ओळख सहाय्यक प्राध्यापक गणित श्री DP गावडे सर व सूत्रसंचालन श्रीमती भोसले मॅडम यांनी केलं. त्याबद्दल मी त्यांचे या ठिकाणी आभार व्यक्त करतो. आणि या कार्यक्रमासाठी विद्यार्थी, सर्व समन्वयक, सहाय्यक प्राध्यापक व प्रशासकीय कर्मचारी या सर्वांनी उपस्थित राहिले. त्याबद्दल मी या ठिकाणी सर्वांचं विशेष असा आभार व्यक्त करतो आणि हा कार्यक्रम संपला असं जाहीर करतो.
थँक्यू. गंगा भोसले. 2008